AT, and then I give them questions. So in the text itself, I give them like 5 questions that they need to answer, and they can do think, pair, share during the class discussion in order to compare their answer if their opinion is acceptable or not. And then for the next one, whatever is the question that is hard for them to answer, then we can discuss it during our big group discussion. For phase 3, we have the small group activity wherein they're going to create water filter. So I give them different materials where they can use in constructing the layers that they can put in their water filter device. So the challenge is for the water filter to be effective as well as with low cost. So I give them like certain price for all the materials that I'm giving them, and then they compare the color with the standard drinking water, and then they can rate this as 1 to 5, and based on that, then they can determine which device is better when it comes to a water filter. Then I also give them a chance to redesign, so that is applying the engineering part to redesign. So if they think that the water is still not clear, then they can choose another set of materials and put it in a layer. And they can compare the first design and the second design to choose the better water filter. So that is for my example of lesson applying the team-based learning. So the activity that we're going to do is I choose some lessons for a specific discipline, and I'm giving it to your group. So one is for biology, one is for chemistry, and one is for physics. So I'm giving you like 10 minutes to do the workshop.
So the biology group was working on a project to help students get to understand osteoporosis. So for phase 1 of the group project, which is the work that they have to do at home, we would say we'd give them some vocabulary words that they would have to define, like parathyroid hormone, growth hormone, calcitonin, as well as do some research on the disease itself, like what are the causes, the risk factors, some statistics. So then when we got into class 2, we could start with phase 2, where we would test their background knowledge before they actually start the group work. So we were thinking of doing some sort of like matching quiz, where we had all the different definitions of the vocab words that they were supposed to look up, as well as all the answers, and if they could correctly pair them, then we know that they're ready to move on to the group project in phase 3. We would basically present students with the problem that they have this patient who has osteoporosis but doesn't know why he has it. And so they'd have to go through the process of creating this case study where they diagnose the patient and come up with a treatment plan in order to solve his health issue.
Thank you very much, Ms. Levine.
You're welcome. Thank you.
So for our TBL in chemistry, we decided that we're going to have, first of all, have the students search the internet for methods to chemically test for water quality. And these were the 4 pollutants we were going to have them research on. The pH of the water, the dissolved oxygen in the water, nitrates, and phosphates. And then also on the internet, there is an online app called Toxicity, where they can go from different parts of the town, and it'll kind of show them what different restaurants and golf courses will kind of dump into the water system. They can research that. And then phase 2, we can give the individual readiness test to the short quiz, and then the GRAT as a warm-up. And then we can have them do any appeals that they need to do to, if anybody thinks that the questions are wrong or not. And then for the application, there's a laboratory investigation where they can apply different types of water, like tap water, inorganic fertilizer, and water that's been mixed with fertilizer. And they can associate that with the different parts of the city that they researched in phase 1.
That's it. Okay, thank you very much. Do you have any questions with regards to the presentation of Mr. Fasoni? Any comment? So is it good or is it well? Okay, it's well presented?
Yes.
Okay.
I think it was a good
Do you have any
presentation
questions?
apparently because he gave them some work and guidelines on how to do their research. So that was good for me.
Okay, thank you very much, yeah.
And it was purposeful.
Yes.
It wasn't just like sending them home with a homework assignment. It was like they were
Yeah.
actually.
So it's just, we don't just give them a homework because for the sake of giving homework. So there's a reason why we're giving them a homework. And at least, when they come to class, they already know what to expect inside the classroom. Right? Yeah.
And also we can use this kind of strategy for when we are, being evaluated for what is that for the interaction among students. And then remember we were advised if you want to get 4, make sure they have this practice of peer evaluation as well.
Yeah.
Right? Other than there is a group presentation and it comes with these activities, the peer evaluation, which is a good thing. It's not just an advantage for the students, also for advantage for us teachers for our evaluation. So
Yeah.
I like it.
Yeah, that's right. And it's like, because one way to determine if the student learned is for them to be able to criticize somebody's work. So actually, that's the highest way of of evaluating if the students really learn, because they will.
Good afternoon, everyone.
Good afternoon.
Yes. What we did discuss in our group, we came out with some 3 major phases, and that for the construction of the roller coaster, which is the end product, we started by giving the students some assignment. They have to do internet research, and also give them books, printed materials from books, for them to read on types of energies. When you do type of energies And we'll also add some practical point of it such that these students should be able to go on the swing and actually see the type of energies that are exhibited during the swing at home. With that, the second stage will be actually the students will be in class. We now test the student knowledge on how energy conservation takes place, how energy is transformed from one type of energy to another. So that way, we'll be able, though our goal is a roller coaster, we'll try to bring the battery, we'll try to bring other devices like that converts energy from one form to another, to actually make sure that students are aware of energy types. So they'll have a short quiz on that. And the quiz will have essentially testing their knowledge of law of conservation of energy, which they should be able to state at the end. If the student have a good or a working knowledge about the law of conservation of energy, at that point, we now move to the application stage where they should be able to build a roller coaster from the idea that kinetic and potential energy are conserved. Before they go into real construction, they'll have to tell me, the teacher, if they can use wood or iron. And they have to give their choices, either because of efficiency or the cost. So at that point, probably we'll expect the students to talk about high friction for wood. If the tracks are prepared of wood, there will be high friction compared to iron. And equally, though iron is expensive, but the efficiency will be high. And again, during the construction, they will now actually, during presentation, the student will present. We will expect them to talk about acceleration, yes, the force of gravity that pulls, see how they can't accelerate, and probably stop when the energy is all exhausted. So that is the nutshell, a big picture of how the construction will look like.
Thank you very much, Mr. Musi. Any comment?
Just a question.
Yeah.
For the homework piece, could you introduce the vocabulary like velocity and acceleration and potential kinetic energy during that time, or do they get that only during phase 2?
They will get that during phase 2. When they come to class, we'll introduce them to the vocabulary, so that they actually implement it in phase 3. So in phase 1, actually, it's just the logical or the conceptual level of reasoning. Yeah. So that.
Well, because I taught physics before, so usually velocity and speed comes in the first unit, right? So they have already a previous knowledge about velocity, speed, and acceleration. So in